Okay, so this video is about thermal energy. Thermal energy is the total energy of the particles that make up an object. We'll explain what that means. Objects are made of particles or atoms, and as those particles or atoms move, that creates thermal energy. So those atoms are constantly moving. So the faster the particles are moving, the more thermal energy the object has. So if you have an object that their particles are not moving very fast, then they would have a low thermal energy. And if the particles are moving really fast and they're very excited and they're kind of bouncing all over the place, then it would have a high thermal energy. So the faster the particles move, the more thermal energy the object has. Thermal energy moves from one object to another in 3 different ways. So remember we said that energy could change from one form to another? Well, when thermal energy changes, it moves through objects, but it does that in 3 different ways. We're going to talk about that. The first way that thermal energy moves is through conduction. And conduction is the transfer of thermal energy through direct contact. And this means that the objects must be touching. So you have 2 objects that are touching each other. The heat or the thermal energy is going from one object to another, and that's through conduction. Conduction can transfer through solid, liquid, or gas. So any state of matter can have conduction. So for example, frying bacon on the stove is an example of conduction. I drew it here. So the pan is touching the hot burner, so they're in direct contact, so that's conduction. And then the bacon is touching the pan. So again, the bacon is touching the pan, which is also conduction. So the heat, the thermal energy is going from the burner to the pan to the bacon. So they're all touching each other, so this is conduction. So conduction, they must be touching. Okay. Convection is a little bit more complicated. So convection is the transfer of thermal energy through convection currents. And we'll talk about what that is in a second. Convection can only transfer in liquids and gases. So if you have a solid, it cannot receive thermal energy through convection, only liquids and gases. The substance closest to the heat source expands, because it gets hot, so it expands, and becomes less dense. So as it expands, it has the same amount of mass, but more volume. So it's taking up more space. So it becomes less dense. Substances with lower density rise. So remember from our chemistry unit, if something has a lower density, then it's going to float or rise. So the liquid or gas rises. Then, as the substance rises, it gets further from the heat source. So the heat source is down here, and as it rises, it gets further away. So because it's further away from the heat, it cools off, and it becomes more dense again. It kind of settles back down. Substances with a higher density sink. So it rises, it gets cold or cooler, it becomes more dense, and then it sinks and heats up, and rises and becomes more dense, and sinks and heats up and becomes rises, and it's this kind of current. So that's what a convection current is. And so I drew that here. So this is our fire here down at the bottom, and this air that's right by the fire warms up and becomes less dense, and it rises. But up here, it's further away from the fire, so it cools off, and then it becomes more dense, and it sinks. And so it's this cycle. Again, it warms up, expands, and rises, contracts, and sinks. It's because of the density of the liquid or the gas. And then lastly, we have radiation. And radiation is the transfer of thermal energy through waves. And it's a little different than the other 2. Radiation can transfer thermal energy through solid, liquid, gas, or nothing. So radiation doesn't even need matter to transfer the heat, which is pretty cool. So the sun radiates thermal energy through space where there is no matter. So outside of our atmosphere, there's nothing. There's no matter, there's no oxygen, there's no air, there's just nothing there. But the sun is still able to give us some of its heat energy to the earth. So there's nothing in between this space, but the waves still travel all the way to the earth. And here I showed that even though the sun is giving off a lot of thermal energy, we only get a little bit of it because we're so far away and it spreads out. So radiation is waves, kind of like this, and it doesn't need any matter to travel. So that's how the sun gets us its heat.